A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, Guwahati, instructor for the NPTEL MOOC course Pavement Construction and Technology, funded by Ministry of Education, Government of India. Today's lecture will be a part of the discussion on the characterization of bituminous-bound materials under the module 3 of this particular course. At the very beginning, I would like to acknowledge the use of text, information, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domain searches. In the previous lecture, we discussed about the paving bitumen, the importance of a bitumen and what tests are normally used to characterize the paving bitumen. Then there are other forms of bitumen which are also popular. There is modified bitumen, cutback bitumen and emulsified. So, we will briefly discuss these use of these, what are these binders and how they and what are the applications to which they are put in the flexible pavement construction. Now, as the term itself says, modified bituminous binders. So, you are modifying the bituminous binders or you are modifying the bitumen, and what is the purpose behind doing this modification? What is there which you want to achieve by adding these, I will say, modifiers to your paving bitumen? So, normally what expectations arrive whenever we do any modification with the bitumen is, first of all, we want to improve the asphalt aggregate bonding, because this is very important. If you have a good bond between binder and aggregate, you will have a good durable mix which will perform better under all different conditions. So, your binding between the bitumen and aggregate has to be good enough. If by any modification, if it gets enhanced, that modification will be always better for the performance. To enhance the aging resistance, we have seen the aging determination in terms of the thin film oven, rolling thin film oven and pressure aging vessel, and we want that the bitumen should age less during the production process and during its service life. So, any modification will help us to make a binder age resistance or aging resistance, or I can say resistance towards oxidation, then that will be preferred. To reduce the temperature susceptibility, as a binder consistency changes with the temperature, binder becomes soft at higher temperatures, will become stiff at lower temperatures, but this is not expected to have a very sharp changes there, that as soon as some temperature is increasing, the binder is becoming soft, and a certain drop is there, it becomes very stiff. So, this susceptibility, or I can say the rate of change of consistency with the change in the temperature should be low. So, that is what it is said, that I will prefer that this modification doesn't makes the binder very stiff at lower temperatures and very soft at higher temperatures. So, this kind of modification which reduces temperature susceptibility will be always preferred. And finally, we want a binder which is resistant towards cracking. It may crack when it deflects, it may crack when the temperatures go down, and it may show some deformation under the heavy loads when the temperatures are high. So, we want a binder to be age resistance, should be resistance to cracking, should be resistance to any deformation in that case. So, this all requirements are there. Bitumen's resistance towards cracking, especially that is a phenomenon at low temperatures, and deformation when binder becomes soft at higher temperatures. And certain modifications are also attempted with some products to add sustainability to these bituminous mixes, like you might have heard addition of waste plastic in modifying the or as a modifier in bituminous mixes. So, binder is modified through the use of waste plastic. So, there we are trying to make use of some waste product in the binder modification, and the product which we want to achieve is to be a good product with a higher performance, and that will be more environmentally acceptable because you are making use of some waste products or alternate materials in their construction. So, these are certain reasons because of which binder is modified. The most common modification takes place with the use of polymers. And the term polymer, which is said, is referred to a large molecule made up of chemically reacting many smaller molecules like called as monomers, and they form large chain and clusters. And we have a ISO specification IS 15462 which states the or defines the different characteristics of modified binder. Under this particular one, these are synthetic products, especially petroleum derived products are there, and they, when it is modified by using these polymers, we call them as polymer modified bitumen. And these polymers are mainly divided into two categories. One is plastomeric thermoplastic polymers and second is elastomeric thermoplastic polymers. This is the one which is more preferred for binder modification, and few examples of what type of polymers are there under these categories. You have polyethylene is there, ethylene vinyl acetate copolymer is there, ethylene methyl acrylate copolymer is there, then ethylene butyl acrylate copolymer is there, ethylene terpolymer is there. These are some of the polymers which falls under the category of plastomeric thermoplastics. And the quite common used elastomeric thermoplastic polymers are styrene butadiene styrene block copolymer, SBS is there, as styrene isoprene styrene copolymer, SIS styrene butadiene is there, styrene butadiene rubber is there. So many other products in addition to this, like waste plastic mentioned, that's also a kind of polymer is there. Then waste tire rubber is also used for binder modification. So, but target is to enhance one or the other characteristics of the paving compared to the paving grade binder when you are modifying it. The test which needs to be conducted is specifically for judging the suitability of polymer modified binder is given by IS 15462. Many common tests are there what we do in case of paving bitumen. In addition to this particular one, for modified binders we need to work out the viscoelastic nature of the binders, and for that a dynamic shear rheometer is used, and many parameters derived from the dynamic shear rheometer analysis are also used to judge the suitability of the different modified binders. And as we were having the viscosity grades of the paving grade binder, similarly here you have the different grades for polymer modified binder also. You can see one grade is 64 PMB 64 minus 10, second is 70 minus 10, third is 76 minus 10, fourth is 82 minus 10, 76 minus 22. So these represents 64 represents the maximum pavement temperature for which this particular binder is suitable, and minus 10 is the minimum air temperature which can be for that particular region. So any region experiencing a maximum temperature around 76 degree and a minimum temperature of minus 10 degree, this PMB 7610 will be suitable for it. So this is, and the different requirements in terms of the parameters, you have some of the one common which were used for paving, like softening point is there, viscosity is there, flash point is there. In addition to this, there are certain parameters which are derived from dynamic shear rheometer to understand the viscoelastic nature, because now we are using modified binders which are incorporating some polymer set. So how good it is getting dispersed, how the compatibility is there between the modifier and your neat bitumen, all these needs to be ensured. So there are different tests and requirements seeing the different grades to be used. Like if we say, and the application of these different grades are also for different regions, as I mentioned, it says that PMB 64 minus 10 having an average maximum pavement temperatures less than 64 degree centigrade and minimum pavement temperatures greater than minus 10, then 64 minus 10 grade can be used. If I look for PMB 76 minus 22 having an average maximum pavement temperature less than 76 degrees, so and a minimum pavement temperature greater than minus 22 degrees. So depending upon in which region we are using, we can select a polymer modified binder grade. In addition to this particular one, it says for different traffic levels also, standard, heavy, very heavy, extremely heavy traffic conditions. Let us pick up for one case, like when it says for very heavy conditions. It says very heavy service conditions, traffic levels of greater than 30 million standard axles, or very slow moving traffic. When the traffic, for that particular case, it is preferred that you select any grade out of this particular one. So this is the requirement here depending upon different regions, and then there is a requirement which is regarding the this is a GNR value. This is again a parameter which is derived from the dynamic shear rheometer to understand the binder's resistance towards high temperature deformation. So on the basis of this one, different modified binders can be selected for use in different regions under different traffic loading conditions also. Now the other category of binder, which is the cutback bitumen. Cutback bitumen, it is, as the word itself says, we are cutting back something. So what we are cutting back here? We are cutting down the viscosity of the bitumen. It refers to a type of liquid asphalt produced by blending or cutting back paving grade bitumen with suitable petroleum distillates. So what when we add these petroleum distillates, we are cutting back or lowering the viscosity of it, and these petroleum distillates are known as cutter stock or diluents. So we are bringing producing this cutback by adding certain petroleum distillates, and we are bringing its viscosity down. And with this particular one, we can apply this one to the aggregates at lower temperatures also, because otherwise when you need to coat the binder over the aggregates at ambient temperatures, it is stiff, semi-solid state. So binder needs to be heated to temperatures around 150 degrees centigrade, and then aggregates also simultaneously need to be heated, and then they need to be mixed up. So this heating can be avoided of binder if the viscosity of binder is already reduced. So that we can do with the addition of these petroleum distillates. Now this process reduces the viscosity of bitumen, making easier to handle and apply at lower temperatures, because now you don't need to heat your aggregates to those high temperatures as well as your binder. It is used in various applications. There are some of them are surface dressing. Patch repairs, is small surface dressing is a type of application which we have discussed in earlier courses, earlier lectures, and to apply a coat when we are going over for a bituminous course over a granular course. So then also a layer of this cutback is applied. We call it as a prime coat. This we will again discuss when we will be discussing the construction aspects of granular courses. Now application to aggregate or pavement causes the solvent to or these petroleum distillates to escape by evaporation and thereby leaving the asphalt residue. So the process works in this particular manner. You prepare an aggregate mix along with it cutback, or you apply the cutback on a surface where some binder application has to be done. So the distillate will evaporate with time and binder will remain on the surface. This is shown an application of a prime coat or an application of a tack coat. Normally over granular courses, when we want to construct over a granular base course, a bituminous course, we will first apply a tack coat, we will first apply a prime coat, and thereafter we will go for a bituminous construction. And if there is an existing bituminous old pavement and you want to overlay it with a new bituminous layer, then that existing also is made an application of a bituminous binder, which we call as a tack coat. This we will further discuss when we will be discussing about the construction of the bituminous courses. Now there are different grades, as there were viscosity gradings VG 10, 20, PMB grading 76 minus 10, 76 minus 22. Similarly, there are different grades for cutbacks also, and they have different applications. Like this is a rapid curing cutback where you are using a distillate which is a naphtha, which evaporates very quickly. So containing, and this particular one is used when you are having no fine aggregates are available. So if you want to prepare a mix with a rapid curing, because the distillate will evaporate very quickly, so you will get a very less time to work with it. So that's why you don't want to have very fine aggregates, because fine aggregates requires a more amount of time for mixing because of their higher specific areas, surface area. And then there is another grade, medium curing cutback, where you are using some diluents like kerosene, and especially here it says that 40% of fine aggregates can be used, and again some heavy oils are used to prepare the slow curing cut bags, and here it says that up to 20% of fine aggregates can be used. So, in this particular one. So, this says now you, in addition to this particular one, there are different grades within each rapid curing cut bag also. There is RC 70, RC 250, RC 800, RC 3000. What it represents, RC 70 means the viscosity, the kinematic viscosity of this when measured at 60 degree centigrade should be in the range of 70 to 140 centistokes. Similarly, for rapid curing 250, the kinematic viscosity when measured at 60 degree centigrade should be in the range of 250 to 500 centistokes. Now, so this gives the idea about the viscosity of that particular grade, and as I mentioned, different applications are there, like for rapid curing 70 grade and rapid curing 250 grades, it is preferred to be used as a tech coat. For medium curing 30, medium curing 70 grades, it is preferred to used as a prime coat. So, this is important to select the right grade for a particular application. Now, the fourth category of binder which is there is your emulsified bitumen or emulsion is there. Now, bitumen and water are two immiscible liquids. Again, here the purpose is how we can bring down the viscosity of binder so that we can make an application at lower temperatures. So, one was adding the petroleum distillates, and second is this particular process which is called as emulsified bitumen. Now, what is done? It is said that mechanical and chemical processes are involved to combine two or more materials that will not mix. Binder and bitumen and water in general will not get mixed. So, this is what is there, they will exist in different phases. Now, what is done here? Bitumen emulsion is a liquid product in which bitumen is suspended in a finely divided condition in an aqueous medium and stabilized with a suitable material. So, what is done here? You have the two components are taken here. You have this particular one water along with an emulsifying agent, and you have a bitumen. So, now you want to mix this particular one. So, what is done here? The bitumen is brought down to small globules, and this water along with the emulsifying agent imparts a charge on your bitumen globules. So, then the bitumen globules remains in a suspended condition. This helps this aqueous medium along with the fine globules of bitumen leads to a lower viscosity, and this emulsified bitumen then can be applied at lower temperatures. So, hot bitumen and water containing an emulsifying agent passed under pressure through a colloidal mill. This is a colloidal mill producing fine droplets of bitumen uniformly suspended in water. This is how it gets suspended. This is how a bitumen emulsion is there. So, the emulsifier, the emulsifying agent which we use can impart a positive or a negative charge. If it imparts a positive charge, it is a cationic bitumen. If it imparts a cationic emulsion, if it imparts a negative charge, it is an anionic emulsion to the bitumen droplets which are dispersed in acidic or alkaline aqueous phase. Now, one of this example is, now this is a cationic emulsion. The emulsifying agent is introducing positive charges over the bitumen globules. So, this particular emulsion will have a more affinity towards aggregate which are slightly having negative charges or which are slightly acidic. Most of the aggregates, siliceous aggregates which are available generally are slightly negatively charged. So, these aggregates will perform better with your cationic emulsions. And again, so cationic an emulsion in which the emulsifier gives the bitumen particles a positive charge while surrounding the water in slightly acidic, and this emulsion breaks when the positive charge is neutralized. So, when you mix it with the aggregates, this gets neutralized, or when you apply on the surfaces, it gets neutralized and the breaking of the emulsion takes place, and after some time the water evaporates and the binder remains over the surface of the aggregate or the existing road surface. Similarly, it is for anionic emulsions where the anion or the emulsifier is at the interface with bitumen and a negatively charged is one and the aqueous phase is alkaline. So, again we have IS 8887 for cationic emulsions specifications, IS 3117 they state certain codal provisions, test procedures to check the suitability whether a particular grade which is supplied by a refinery or a bitumen modification plant is to the standard or not. So, we need to check as per the requirements of these IS 8887 for cationic emulsion, IS 3117 for your anionic emulsion. And as I mentioned, again here there are 5 grades. This is rapid setting grade 1, rapid setting grade 2, medium setting grade, slow setting grade 1, slow setting grade 1, and they have different applications. Rapid setting 1 can be used for tack coat, surface dressing work, penetration macadam, surface dressing, prime coat applications, and for this slow setting 2 can be used for producing mixes like semi-dense bituminous concrete mix, which we discussed, and the other or your mix seal surfacing or slurry seal. So, depending upon the grades, different applications of this emulsifying. But the concern with both of these binders is, in one case the distillate is lost to the environment. So, that makes, because we are losing some costly products to the environment. So, from the cost aspect also, from the environment aspect also, it is not good. The challenge which takes place with emulsifying asphalt, this is in both the cases you do not require to heat the binder, as well as aggregates also does not require to be heated to those high temperatures which you require to do in case of paving bitumen. But in case of emulsified asphalt, when you are making use of emulsifying asphalt, when water evaporates, it leaves spaces. So, if you are having a mix in it, so when the water evaporates, the void spaces are created because of the evaporation of water. So, the density is less. So, that is why there are certain things which needs to be taken care when you are making use of these emulsified asphalt prepared mixes. Now, with some of the aggregate test we discussed when we were discussing the granular courses, characterization of materials for the used under the granular courses. In addition to those requirements, there we discussed about the Los Angeles aberration value, we discussed about the aggregate impact value, wet aggregate impact value, combined elongation and flakiness index, soundness test, a sort of durability test which we also discussed. In addition to there also water absorption value was there. Polished stone value is another test which is required specifically in bituminous bound courses, inflexible pavements because it is used as the top course. Stripping test is required, water sensitivity test, cleanly test, and sand equivalent test, because you do not want your surface to have these kind of things where you are able to see this loss of material is there, potholes are created. Here you are seeing fines are disintegrated conditions, there are fines are lost. Again, this is these kind of situations you want to control. So, you need to check your binder as well as your aggregates to the best of the requirements, the latest standards available. Now, first of all, when we are looking to the aggregates part from the bituminous bound aspect, the coarse aggregates, fine aggregates, and the filler are the 3 proportions which we have discussed. There also we discussed that when we are using any crushed gravel, at least 95% by weight should be retained on 4.7 have 2 or more fractured faces. So, this is one important requirement. Rest it says that the coarse aggregate to be used in bituminous bound courses should be clean, hard, durable, of cubical shape, free from dust, soft or friable material or organic or other deleterious matter. So, this should be ensured whenever any source of coarse aggregate is selected. Fine aggregates, it says in fine aggregates, especially when you are using in the binder and the wearing course. Wearing course is the top course below which comes our binder course. So, when these 2 courses of flexible pavements are there, we will not prefer to use natural sand in these 2 courses. If we go a course lower than the binder course, which will come as your base course, we can use only 50% from natural sand, because natural sand does not impart you a good resistance towards deformation. It is completely rounded up, so there is a lot of chances that the particles doesn't get interlocked in a good manner, and when the traffic comes over that particular bituminous course or stresses comes over it, it gets deformed. So that's why the percentage of natural sand is controlled or is limited. It is not allowed in case of binder and wearing courses, and if you used in a course lower than binder course, especially bituminous bound course, then only up to 50% it can be used. And in addition to this particular one, there is a requirement that the fine aggregate should have a sand equivalent value not less than 50, because this in one or the other manner try to ensures the amount of the clay content which can be there, the fineness of that particular material. So we want to avoid the clay content in this one. This can be also ensured through the plasticity index requirement which is given. It says that the plasticity index of this material should not exceed 4. So this is another requirement which is mentioned for fine aggregates. So we have in terms of the requirement of sand, we have in terms of the requirement of plasticity index, we have the requirement in terms of sand equivalent value. Then comes the filler, the finest one. Normally the material passing through 75 micron in the range of 85 to 100% material should pass through this particular one. Then this is normally your filler is called as the material which usually passes in this percentage from 75 micron sieve size, and this material can be a rock dust which is produced from stone quarries, can be a hydrated lime, can be a cement. And again here we are going to check for the plasticity index, and it should not be more than 4, and this plasticity index requirement can be omitted if the filler is your cement or lime, because they are non-plastic materials. Now what is required here? We need to look into the cleanliness part, or we can say the grain size analysis part. The one requirement is that the aggregate has to be clean. Whenever the aggregates are produced or stockpiled in any crusher plant or a hot mix plants, chances are there that contamination with some local soil, natural soil or clay may happen, or a lot of dust coating may be there. So that needs to be ensured. So it says that we need to take samples for different sizes. It says the nominal size of aggregate can be 4.75, 10 for each. How much amount of material is to be taken up, and then we are going to sieve it, and what we are going to see is that here B is original dry weight, your C is the dry weight after washing. Wet washing is to be done, and this is to be done through 75 micron sieve. So all fines should pass, and we will see how much percentage of fine is to be there. So this percentage needs to be restricted when you are using any material in bituminous bound courses. So any fines which got stuck to these coarse aggregate particles should be within a given limit only. Otherwise, if this dust is more over an existing aggregate surface, the bonding of a bituminous binder with this aggregate will get affected because of the presence of this dust in between the binder and the aggregate surface. Sand equivalent value, as I mentioned, this is again to get an idea about the how much amount of clay is present here. So sand equivalent value, this test is to be conducted as per IS 2720, and here specifically a own dried sample is taken, and we prepare a solution which we will put up in this cylindrical measure, and then the sample, your fine aggregate sample is to be introduced into it. It has to be allowed to settle for a period of time, then you are going to agitate it, then it is again allowed to settle, rest for a period of time, and then finally you are going to see, here you can see the reading is there. There is when it gets settled down, you are going to lower it down. It says that after which a weighted foot assembly is gently lowered and it rests. This is the assembly which will be lowered, and it rests over this particular one, where you can see a face, two different layers are there. One is for your sand and second for is your clay. So you are going to measure the sand height and you are going to measure the clay height, and it says that the sand equivalent value is sand reading upon clay reading. So at least it should be greater than your 50%. This is what requirement we saw in the previous slide. So this controls the amount of clay which can be present in your fine aggregates, because the clay, and we are ensuring through plasticity index also, but we are going to ensure through sand equivalent value also to control the presence of fine materials. Water absorption, certain aggregates may have a more superficial voids, and they may require a lot of, they may capture a lot of water, specifically when they are lying open. So the water so when aggregates are produced at crushers and they lie in open spaces during rainfall events, they will absorb some water. So one is the natural moisture content which is present, and if these surface voids are more, when these aggregates will be used with any bituminous binder, these surface voids will occupy more amount of binder also. So this will make your mix more costly, because the binder which goes into these superficial voids will not helping you to develop any bonding or strength, because it goes inside the surface voids. So to ensure this particular one, we check the water absorption of the aggregates, that how much amount of superficial voids are there. This is how it looks like. This is an exaggerated view. You can see these surface voids are there. So these surface voids gets filled up with water if I keep these aggregates in water for say 24 hours. Now once, and I'll take it out and I'll rub smoothly, gently the surface water which will be present. Only the water which will be there within these voids will be considered for water absorption. And when this is done, this condition is known as your saturated surface dry. So you have saturated the aggregate particle, and it is, the surface is also dried. So this condition is required, and what we want to have, saturated surface dry condition minus oven dry condition divided by oven dry condition or oven dry weight. This gives you the water absorption, and normally a limit of 2% is, in most of the cases, is given for water absorption, that the water absorption should be less than 2%. So in case when there is an oven dry, there is no moisture will be there. Air dry, some amount of moisture may be present. Saturated surface dry, all surface voids are to be there, and when it is left in air, then there may be some extra water which may be present over the surface also. So this is saturated surface dry to wet condition. What you have is is surface moisture. So here in this case, once you submerge the aggregates in the water, take it out, you remove all surface water by gently using any towel or cloth, and then what you get is your saturated surface dry. And these two, oven dry weight and saturated surface dry weight, are used to determine the water absorption. Another parameter which is used is the stripping value of your aggregates. Now this test is used to judge how good the binder is coating with your aggregates, especially because binder source will be more or less having in general a good affinity with the aggregates, but certain aggregates are having more affinity towards water compared to bitumen, and certain aggregates have more amount of water absorption, surface voids. So we want to see whether how good that aggregate forms a bond with a given sample of bituminous binder. So for this one, we'll prepare a mix with a given weight of aggregate, we'll add a binder to it, and this is to be done as per the codal specification. Aggregates are to be heated to a particular temperature, binder is also to be heated, 200 gram of sample of aggregate taken, around 4% of it, 8 gram of your this bitumen is to be taken, both of them are to be mixed together. Then you need to transfer it to a cylinder, a measure where it will be covered with water, and before subjecting it to this particular one, this mix which is prepared, it is kept in oven for around a period of 2 hours at the temperature at which this mix is produced. Why it is done? So that all these surface voids which are there on the aggregates will absorb the bitumen. So the surface voids and it will also lead to a small amount of what we are expecting, some amount of binder absorption into the aggregate surfaces. So this conditioning is done. So once the mix is prepared, the mixture is conditioned in oven for 2 hours and then transferred to a beaker containing 500 ml of water, and then this water is boiled. So this mix is kept in that boiled water for a period of around 30 minutes. So At these high temperatures, if there will be in the presence of water, if the binder film gets removed, in due course of time you may have some binder coming on the top of water, you will keep on removing it, and finally after this 30 minutes of boiling of water, you will take out the aggregates, cool it down, and then you will see what are the aggregates where the binder film has been removed. So this can be seen, the brownish surface as well as the completely stripped surface are considered as stripped area. So this is the portion or the aggregates area which are having binder stripping, removal of the binder, and these are the remaining one where I have the coating still available over the aggregate. So this stripping value is the uncovered area observed. This is a visual examination, and total area. So normally it is expected that this coating should be at least more than 95% available. So this is done through visual observation and to get an idea how good the coating is. Now one more test which is done on polished specifically for the aggregates which are used in the top courses of bituminous, especially the wearing courses, because they are under continuous rubbing action of the traffic. So we want to see the relative measure of the extent to which different types of road accidents in the wearing course will get polished under the traffic. So this is one test where what is done, we prepare some samples and we will subject them to some accelerated polishing action. This is a polishing machine is there, a wheel is there. So this wheel is run over this aggregate surface and we will polish it in the presence of water, emery powder, so that this aggregates gets polished, and we want to see how much a particular source of aggregate gets polished. We want an aggregate to have a good resistance towards polishing, and once this polishing, an unpolished aggregate and a polished aggregate will be checked through British pendulum tester. This is one where a pendulum is there, it rubs over the surface of these aggregates which are in an unpolished state and a polished state. If they are having if they doesn't get polished because of this action, then they will generate a good amount of friction. If they get highly polished, the friction generated is less. So this friction between the abrasive action or the polishing of this aggregates is measured with the help of estimated through this British pendulum tester, or we can call it as a pendulum tester, and we believe there are readings given for it. It says that this should be having a value of more than 55%. That if you have the aggregates which needs to have good polishing towards this particular one, the value of polished stone value should be more than 55%. So this is again a test which is done for aggregates to ensure that it doesn't get highly polished under the, otherwise if they get highly polished, then chances are there that skidding or the friction gets reduced. So we want aggregates to have good polishing resistance. And then this is one table showing what are the requirements for a mix to be used in aggregate requirements to be used in bituminous macadam, dense bituminous macadam, bituminous concrete, stone matrix asphalt, open graded friction courses, and all mixes is specified by different IRC and MRTH one, and there is a requirement of cleanliness, that 5% passing 75 micron particle shape, which is your combined elongation and flakiness index, 35%, Los Angeles aberration value, impact value. You can see for different mixes the requirements may change. What in this case, what is that particular mix, what its purpose. Stone matrix asphalt, they require aggregates to have a high resistance towards the impact. So they need to have a good tough aggregates. That's why the aggregate impact value has to be less than 18% for use in stone matrix asphalt. Then we have the soundness one, water absorption one, stripping value one, minimum coating 95%. Water sensitivity, this is another test which needs to be, which we will discuss when we will discuss about the mixes in the coming slides. Then the polished stone value, especially it says minimum value should be 55. Now under this bituminous bound courses, we discussed about some requirements for the binder to be used, the aggregate to be used. Once you prepare a mix which is having an aggregate, different sizes of aggregates bonded together with the bitumen, then finally this is the mix which is going to be laid in the field. So this mix need to be ensured for different characteristics, and for laboratory evaluation we prepare cylindrical specimens through these combinations of bitumen and aggregates. Now these may be of 4 inches of dia or 6 inches in dia, varying from a height of 2.5 inches to 4 inches or even more than that. The conventional sizes normally which is used are of 4 inches dia and around 2.5 inches height or 2 inches of height. So we will prepare these specimens and we will try to ensure some properties of these mixes so that they are resistant towards this kind of cracking, any deformation which can happen. This is shown as a rutting, deformation is there. They should have a good bonding with the aggregate which is there. This binder should not become soft enough. So we are going to check finally these mixes, because this is the mix. We have individually ensured aggregates and binder. Now we are going to ensure for these mix also. So and 2 parameters and these characteristics of the bituminous mixes are used in the design of your flexible pavements also. So it says that a bituminous bound mix is to be strong and durable enough to handle traffic loads and environmental factors like temperature, rainfall and ultraviolet radiation, which will happen during the service life of it. So here it says that the mix material should be sufficient strength to resist both tensile and shear stresses, because there will be some deflection which will happen. So tensile stresses will also generate, and there will be compressive stresses as well as shear stresses which also get generated when the traffic load comes over the surface. So and this is more especially in the bituminous mixes. So 3 parameters mainly evaluated for the bituminous mixes. There are many more parameters, but the 3 basic parameters which are ensured during the design of these bituminous mixes, one is the Marshall stability. It is in this particular one a cylindrical specimen which is prepared at a laboratory with a particular combination of aggregates and binder is subjected to a loading in this particular one. This is a confined loading, compressive loading which is given here, and we measure this one. The sample is inserted in this particular one and a load is applied at a standard rate, and we are going to see how much is the deformation which is happening in this specimen and how much load it takes before the sample actually fails. So 2 things, the maximum peak load is measured and the deformation which happens at the maximum load. This is one parameter, and the rate of loading also there is standard at what temperature it has to be done, at what rate of loading. This we will again discuss when we will discuss the design of bituminous mixes. And then there is a requirement that for a particular kind of mix, the minimum stability, that means the minimum amount of load it should take is 9 kilonewtons. So that means 900 kg weight load it should take before it fails, and there is a requirement of Marshall flow also. So this is one requirement which is there for the strength, to ensure the strength, which is checked during the design of the bituminous mixes. Second is the moisture sensitivity test. This is once the mix is prepared initially, in the initial period when the mix is not densified to that particular state, because in due course of life it gets densified by the traffic. So there in that case we need to ensure the change in the strength of it. So specifically we are trying to ensure the moisture induced damage in these compacted bituminous samples. So this is moisture sensitivity test is a widely used to measure the change of diametrical tensile strength resulting from laboratory accelerated moisture conditioning, which includes a freeze and thaw cycle of compacted HMA specimen to check the moisture damage resistance. Now what is done here? We are going to check the indirect tensile strength. Here it is again cylindrical specimens which we use for the Marshall stability. Similar specimens will be used here in this case, and we are going to determine its indirect tensile strength across its vertical diametric plane at a specified. So this is how this is a specimen whose dia will be around 4 inches and the depth may be around 2.5 inches. So this will be loaded along the vertical diameter in this particular one. So there is a plate which is kept at the bottom, on the top also, and then from this load is applied, you can see, and here these are LVDTs which are measuring the horizontal deformation in addition to the vertical deformation. This is a setup which has shown. So, a diametrical plane, the loading is done at the diametrical plane for this particular one, and to get the peak load at which the sample fails. So, this gives you an idea about the tensile strength of this specimen, and the expression which is used is IDT, ST is the IDT, indirect tensile strength in kilopascals, where your P is maximum load in Newton, and T is the specimen diameter, which is normally 2.5 inches, and your D is the specimen diameter, which is 4 inches. Here it has to be given in mm. So, 101 around 101 mm, this may be around, say, from varying from 50 mm to 60 mm in that case. So, this gives you indirect tensile strength of a compacted specimen. Now, for looking into the moisture damage resistance, this specimen is subjected to different moisture conditioning environment. In one case, what is done, this sample, for an unconditioned sample, the mix is kept at 25 degrees centigrade in a water bath to bring its temperature to 25 degrees centigrade. In second case, the mix is first produced at a definite amount of air void content and then saturated. So, we are intentionally saturating that mix with water. So, water enters into the mix with an application of vacuum, and then finally, once the water has entered, the specimen has got saturated in the range of 70 to 80%. It is subjected to a freezing action of minus 18 degree for 16 hours, then again thawing for at 60 degrees centigrade for 24 hours. So, this is one in one manner giving the cycles of freezing and thawing to the specimens when it is saturated with water. So, trying to simulate the moisture related damages which can happen in the bituminous mixes. And then finally, again this conditioned specimen also brought to 25 degrees centigrade by keeping in water bath for 2 degree. So, now this is a conditioned set, this is an unconditioned, and we are going to again measure the indirect tensile strength for both of these conditioned set as well as unconditioned test, and a ratio of this particular one will be called as the tensile strength ratio. So, a mix which is more resistance to this particular one, there this value will be higher, and a mix which will be lesser resistance towards this moisture induced damage will have a lower value of this one. And for most of the mixes, it says it should be more than 85%, certain requirements even may say more than 80%, some may say more than 90% also, depending upon different requirements. It says that the tensile strength ratio should be more than 80%. Most of the cases it says it should be more than 80%. And this parameter, which is the last one, again very commonly used for judging the strength of bituminous bound courses, is the resilient modulus. The term itself says is the resilient modulus, which is the elastic modulus, because this is the parameter which is used in the design of flexible pavements in India, which is done as per IRC 37. So, here it says resilient modulus is the parameter which takes into account only the elastic or resilient component of the deformation of the specimen in a repeated load test. So, here again a specimen is in this particular resilient modulus test is subjected to repeated load. This is a specimen which is shown here, which is placed in this particular test assembly of resilient modulus, and what is done is you are going to apply a strain over it, and this particular one stress, and you are going to measure what the strain is happening. So, you can see there is a elastic strain, and when these repeated loadings will be there, in due course of time, what will be this mix will be experiencing, there will be a certain component of strain which is not recovered. If I load a specimen and I remove the load, when I load the specimen, some amount of strain will be there, deformation will be there, and when I remove the load, this deformation gets recovered. Now, there may not be a complete recovery of this deformation. A part of it may recover and a part of may remains there, that is the permanent deformation, and a part of it may get recovered. So, here you can see when there is a total strain which is applied, out of which certain amount of, this is one cycle. When you give a load, a strain is there. When you remove it, then the strain gets reduced, but still at the bottom some amount of permanent strain is removed. Next loading cycle, again strain comes. When removed, again it goes back, but in due course of time some amount of permanent strain will be there, or we will call as a plastic strain or accumulated strain, and some amount of this recoverable strain is there. And this recoverable strain is the one which is required to get your resilient modulus. So, resilient modulus is your stress divided by your resilient strain. So, this is the elastic strain, and this parameter is required as a strength parameter when as an input when you do the flexible pavement design for your flexible pavement design to compute your crust thickness. And in this one, again this is a diametrical loading which is done here, and the resilient modulus is computed as the load which is given. P is the repeated vertical load, and again what amount of load has to be given, at what parameter it has to be checked, all are as to be as per the IS codal provision, as well as here we are going to form the ASTM codal provisions to conduct the resilient modulus test. It says P is the repeated vertical load, H is the total recoverable horizontal deformation. This is what the resilient strain which we are going to monitor. H is the mean dimension of the specimen, and mu is the Poisson's ratio, which is a ratio of your lateral strain to the longitudinal strain. So, for most of the cases this is taken as 0.35. Now, this is one parameter again. So, we need to ensure the aggregates also, binder also, and mixes also. There are many more parameters, many more tests which are done on aggregates, bituminous binder, and the mix, especially the ones, the compacted mixes, to ensure their suitability for road construction or for flexible pavement construction. The one I have discussed here are the one which are quite common, most common is specified, the binder part for paving bitumen, the aggregates for most of the common courses, and the one for bituminous bound which are as per the design requirements for bituminous mixes. So, this is all for the different tests for the characterization of bituminous bound courses. Thank you so much.